Hello, dreamers, wanderers of the night sky, and welcome back to the Wandering Neuron. Tonight, we're going to drift slowly, calmly, into the very fabric of reality itself. We'll talk about something that sounds like it belongs in both physics and poetry, the fabric of space-time. Is it real? Can it stretch? Can it even tear under the unimaginable weight of black holes? Like a gentle lullaby of the cosmos, we'll take this journey step by step. You don't need to know equations, or math, or even science in detail. All you need to do is relax, listen, and let your imagination float across the universe. So, close your eyes if you want. Feel your breath, steady and calm, and picture yourself drifting through a quiet night sky where stars shimmer faintly like distant lanterns. Out there, beyond the stars, lies a question. What is space-time, and what does it mean for it to be called a fabric? Imagine you're lying on a soft bed. The sheets beneath you stretch smoothly in all directions. Now, instead of a bed, imagine the sheet goes on forever. No end, no edge, just a smooth, endless stretch. That sheet is our metaphor for space-time. Space-time is not just space, not just the three dimensions around you, left and right, up and down, forward and backward. It is also time, woven into the very same cloth. Einstein taught us that time is not a separate ticking clock in the background. It flows differently depending on where you are, how fast you move, and what surrounds you. So the universe is not just a stage where things happen. The stage itself bends, flexes, and dances depending on what is on it. When physicists say the fabric of spacetime, they mean this invisible stage, a grand cosmic sheet upon which galaxies, stars, and black holes rest. And every bit of matter, no matter how small, tugs on that sheet. Just as if you placed a marble on a trampoline, the fabric dips ever so slightly. The Earth, the Sun, and even you, dear listener, gently bend spacetime. Now, let's slow down. Take a breath. Imagine again that endless cosmic fabric. It isn't visible, you cannot touch it, and yet everything you do is shaped by it. When the Earth orbits the Sun, it's not because of some invisible rope pulling it around, it is because the Sun bends the space-time fabric, and the Earth is simply rolling along that curve, like a marble circling a dip in a sheet. No force pulling, no rope attached, just the natural flow of the fabric. And when we say black holes bend spacetime, we mean they press down so heavily that the sheet seems to sink without end, a bottomless pit in the invisible cloth of the universe. This image of fabric helps us imagine the unimaginable. Of course, the reality is even stranger. Space-time is four-dimensional, not just a two-dimensional sheet. But for our sleepy minds tonight, a fabric will do just fine. So, as you rest, think of yourself lying on that infinite sheet, floating, held gently by the curves of the universe. Picture yourself sitting beneath a night sky. The stars seem so calm, so eternal. But just over 100 years ago, a quiet man with wild hair, Einstein, looked at that same sky and dared to say, "What if everything we thought we knew about space and time is wrong?" For centuries, people believed space was just an empty container, an invisible box where planets floated, where stars burned. Time, they thought, was like a universal clock, steady, absolute, ticking away the same for everyone, everywhere. But Einstein's mind didn't rest. He asked questions others had ignored. Why does light bend near the sun? Why does gravity seem so strange? acting at a distance, pulling planets in their paths? And could time itself slow down? His answer became one of the most beautiful ideas in science: general relativity. Not a force pulling things mysteriously, not an invisible hand reaching across space, but rather the bending of space-time itself. Imagine that. Gravity isn't really a force, it's the shape of reality. And in that single idea, Einstein transformed how we see the universe. Let that thought rest in your mind for a moment. The next time you look at the moon, remember, it isn't being pulled by Earth, it's simply sliding gracefully along the curve that Earth's mass makes in spacetime. Doesn't that make you wonder what other secrets might be hidden in the very fabric of reality?
Now, let's lean closer to this mystery. Take a moment to imagine space-time again, as that soft fabric stretched under you. What happens if you place something heavy on it? It sinks. The sheet curves downward. This is what planets and stars do. Their very presence changes the shape of space-time around them. But here comes the part that makes it feel like magic. Even light, which has no mass, which weighs nothing, is forced to follow these curves. If space-time bends, light bends with it. That means when a star passes behind the sun, its light bends around the sun's warped space-time and reaches us anyway. And we see the star in a slightly different place in the sky. Einstein predicted this, and in 1919, astronomers confirmed it during a solar eclipse. The world gasped. Suddenly, the universe was stranger and more fluid than anyone imagined. Mass tells space-time how to curve, and space-time tells matter how to move. Doesn't that sound like a cosmic dance? As if the stars and galaxies aren't just floating in space, but weaving across an invisible pattern, choreographed by the universe itself. And if the sun can bend space-time, what about something heavier? Something so massive, so dense, that the fabric doesn't just bend, but nearly tears. Hold that thought, because that's where black holes enter our dream. Now, you might think, this is beautiful but far away, just stars and galaxies in the deep cosmos. But space-time curvature is not only out there. It touches you, here and now, in the quiet of your room. Did you know that every time you use GPS on your phone, you're relying on Einstein's relativity? The satellites above Earth tick with atomic clocks, but time runs differently for them than it does for us on the ground. Why? Because Earth's mass bends space-time, and that changes the rate at which time flows. Without correcting for relativity, your GPS would be wrong by kilometers every single day. Even here, on Earth, the fabric of space-time stretches beneath your feet. Your weight presses ever so slightly into it. The planet bends time itself. Clocks kick just a little slower on the surface than they do in orbit. So as you listen tonight, remember, you are already living in curved space-time. You are already part of this invisible dance. The floor beneath you is not just supporting you, it is holding you gently against the slope of Earth's space-time well. And that's the quiet miracle of Einstein's insight. It doesn't just explain the stars, it explains you, right here, right now. And yet, if ordinary planets bend space-time this much, what unimaginable things happen near a black hole? Let's float there next. Imagine a star far larger than our sun. For millions of years, it burns brightly, fusing atoms together in a nuclear furnace, glowing like a cosmic beacon in the dark. But eventually, even stars must die. And when a massive star collapses under its own weight, something extraordinary is born: a black hole. Now, don't picture it as just an empty hole in space. Picture it instead as a place where space-time itself has been pushed. beyond what our minds can easily imagine. Here's the curious part. A black hole isn't really a thing. It's more like a region, a place where the rules of physics bend, twist, and nearly break. The fabric of space-time doesn't just sag under its weight. It caves inward endlessly, like a funnel without a bottom. And here's what makes black holes so haunting. They are invisible. No light escapes them. No telescope can truly see what lies inside. All we can detect are the whispers, the light bending around them, the stars dancing strangely nearby, or the faint ripples they send across the cosmos when they collide. They are silent, dark, and yet more powerful than anything we know. Doesn't that make you wonder? If space-time is a fabric, what happens when it's pulled this tightly? Can it actually rip? Or does it just fold into something beyond comprehension? Hold on to that thought, because to understand, we need to approach the very edge. Now, picture yourself drifting toward a black hole. There's no rushing, no panic, just a slow, inevitable pull. Ahead of you lies a boundary called the event horizon. This is not a surface, not a wall, not something you can touch. It's simply a threshold, the point where escape becomes impossible. On one side, you can still turn back. On the other, even light, traveling at the fastest speed in the universe, cannot return. To the outside world, time seems to slow as you approach this horizon. Your movements stretch, your image freezes, fading into darkness. But from your perspective, drifting quietly forward, time feels normal. You cross the boundary without noticing. And once inside, every path, every future, every possible direction leads inward. The event horizon is like a cosmic one-way door. And beyond it lies the deepest mystery of all. What truly happens inside a black hole? Some say space-time continues to collapse, shrinking into a single point of infinite density, a singularity. Others wonder if the fabric of reality tears open, spilling into another universe entirely. We don't yet know. But isn't that deliciously mysterious? To think there are places in the universe where even our best theories fall silent. Now, let's step closer, softly, to the most curious effect of a black hole's gravity. Physicists call it spaghettification. It sounds playful, even silly, but it describes one of the strangest ways space-time can behave. Imagine your feet are closer to the black hole than your head. The pull on your feet is much stronger than the pull on your head. This difference stretches you, long, thin, like spaghetti. Of course, in reality, this process would be violent. But let's imagine it instead as a dream. A slow, gentle stretching, like being pulled into a long thread of light, drifting into infinity. Your atoms would align, stretched along space-time's curve. From far away, it would look as if you faded into nothingness at the edge of the horizon. But from your perspective, who knows? Perhaps you'd feel yourself becoming one with the very fabric itself. Some physicists wonder, does information, the story of what you once were, survive this process? Or is it erased forever, lost to the void? Stephen Hawking believes black holes aren't completely silent. He said they glow faintly with something called Hawking radiation, slowly evaporating over time. If that's true, maybe the secrets that fall inside are never truly gone.
And so, as you drift deeper into this thought, you might ask, is a black hole the end of everything or the doorway to something new? Close your eyes for a moment and picture the fabric of space-time again. Smooth, endless, silent. But now, ask yourself, Can a fabric be stretched too far? Can it tear? Physicists wonder about this too. When black holes collide, they ripple space-time with gravitational waves. We've detected these ripples on Earth, tiny tremors in the universe's fabric. But ripples are not rips. So far, there's no evidence space-time has ever torn. Still, the question lingers. If enough force, enough pressure were applied, what then? Some theories suggest that at the center of a black hole, where we expect a singularity, space-time may reach its breaking point. The equations we trust begin to fail. Infinity appears where it shouldn't, and that makes scientists uneasy. Others imagine cosmic catastrophes, a big rip where dark energy tears the universe apart, naked singularities where the core of a black hole is exposed, unraveling space-time itself. If space-time really could tear, what would that even mean? Would reality itself lose its thread? Would time stop flowing? Or would something entirely new emerge? Another cosmos, another dimension. These aren't nightmares. They are dreams of science, places where imagination meets the unknown. And as you drift tonight, let that curiosity sit softly in your mind. Is the universe unbreakable? Or is it secretly fragile? Now let's imagine something even stranger. What if space-time doesn't just bend or ripple? What if it folds? Picture a sheet of paper. Draw two dots far apart. Now fold the paper until the dots touch. Suddenly, what seemed distant is right next door. This is the idea of a wormhole, a tunnel through space-time linking 2 points instantly. Einstein's equations allow for such bridges, and many physicists have wondered, could black holes and wormholes be connected? Could one side of a black hole lead not to destruction, but to a hidden doorway? Science fiction has played with this idea for decades. Starships diving into wormholes, explorers stepping through cosmic tunnels to other galaxies. But the truth is quieter. If wormholes exist, they might collapse instantly, or require exotic matter with negative energy to keep them open. And yet, the thought is irresistible, because wormholes are not just shortcuts in space, they're shortcuts in time. Through them, one could, in theory, step into the past or leap into the future. Curious, isn't it? The same equations that explain how your GPS works also whisper about portals to other times and places. As you drift, imagine yourself floating through one. A soft tunnel of stars curving around you. No sound, no resistance. Just a quiet slip. From here to somewhere else. Now let's shrink our perspective. Smaller, smaller, until atoms are giant compared to where we're going. At the very tiniest scales, the Planck scale, space-time may not be smooth at all. Instead, it may froth and bubble like foam. Physicist John Wheeler called it quantum foam. At these scales, space-time fluctuates wildly. Tiny wormholes appear and vanish in the blink of an eye, Little bubbles of reality pop in and out of existence. This hidden chaos is invisible to us. It only lasts for unimaginably short moments, but perhaps it's the foundation of everything. Think of it like the ocean. From far away, the surface looks smooth, calm. But up close, it's full of ripples, waves, sprays, and swirls. Space-time, too, may hide its own restless sea beneath the smooth illusion we see. If space-time foams at the smallest scales, then maybe the tears, the wormholes, and the bridges we dream of already exist there. Microscopic, fleeting, beyond our perception. Perhaps every moment tiny universes are born and die in this froth. Perhaps the building blocks of reality are not particles, but the bubbling patterns of space-time itself. Doesn't that make you wonder? When you look at the night sky, you see stars. But beneath it all, the universe may be quietly fizzing like a hidden ocean of possibilities. Around 13.8 billion years ago, the universe was born in an event we call the Big Bang. But don't let the name fool you. It wasn't a bomb exploding into empty space. It was space itself, stretching, expanding, awakening. The fabric of reality wasn't torn apart. It was woven from nothing. In the first fraction of a second, all of space-time came into being, carrying energy, matter, and the seeds of everything we see around us. Galaxies, stars, black holes, even you. All of it comes from that first cosmic breath.
But here's the truly strange part. If space-time itself was born in the Big Bang, then asking what came before may not even make sense. There was no before. The fabric of reality is its own clock, its own ruler, its own stage. Now let's drift into the next moment of the universe's dream, cosmic inflation. Picture space-time as a brand new sheet, warm and soft. Suddenly, in less than the blink of an eye, it stretches faster than the speed of light. Galaxies don't fly apart. Instead, the fabric itself expands, carrying everything with it. During inflation, the universe grew from smaller than an atom to the size of a grapefruit in a fraction of a second. If you tried to watch it unfold, you'd miss it in the time it takes to blink. But this inflation didn't just stretch space, it smoothed it out. The reason our night sky looks the same in all directions, calm, uniform, almost sleepy, is because space-time had this dramatic, frantic stretch before slowing down. But physicists whisper about something even stranger. Inflation may not have stopped everywhere. Some regions could still be inflating today, spawning endless pocket universes, parallel fabrics, each with its own physics, its own galaxies, perhaps even its own versions of you. The Big Bang created the fabric. Inflation stretched it wildly. And now, billions of years later, something else has taken over. Something mysterious, something we still don't understand. We call it dark energy. It's as if space-time itself has a hidden engine, quietly humming in the background, pushing galaxies away from one another. The farther a galaxy is, the faster it drifts from us, as though the cosmic fabric is tired of holding still. Here's the eerie part. Dark energy makes up nearly 70% of the universe. That means most of the fabric we float on is powered by something invisible, unmeasurable, and deeply strange. Some scientists think dark energy is woven into space-time itself, a kind of tension in the fabric. Others wonder if it's pointing to something even bigger, a deeper layer of reality beyond our universe's weave. Imagine a place where the cosmic fabric is no longer strong enough to hold its own weight. A star, massive and ancient, burns through its fuel. Without its fiery push outward, gravity wins. The star collapses inward, crushing space-time like a hand squeezing fabric into a knot. A black hole is born. At its center lies a singularity, a place where the equations of physics no longer work. Space-time doesn't just bend there, it snaps into something we cannot describe. Around it forms the event horizon, the point of no return. Step across and even light, the fastest traveler in existence, cannot escape. Some physicists describe black holes as tears in the fabric of reality. Others see them as perfectly normal patches of space-time, just extremely curved. Either way, they remain nature's most dramatic reminder that this fabric is not unbreakable. Now let's drift into a thought experiment. If black holes are knots in the fabric, could there also be tunnels? Einstein's equations suggest the possibility of wormholes, shortcuts through space-time that connect two distant points. Imagine folding a sheet of paper so its ends touch, then poking a hole through. Suddenly, the journey across isn't long and winding, it's just one step. But here's the catch. Wormholes may exist only briefly, collapsing before anything can travel through. Others might be stable only if held open by exotic matter, stuff with negative energy that we've never seen. And yet, the math doesn't forbid them. Which means, somewhere out there in the cosmic dream, space-time may have built its own hidden corridors, waiting for curious travelers. This brings us to the ultimate question. Do black holes actually tear space-time? If you fall toward one, the stretching of time and space becomes unbearable. To an outside observer, you slow down, freeze, and fade at the event horizon. To you, inside, time races toward the singularity. From your perspective, space-time doesn't just bend, it shatters. Some theories suggest black holes could be gateways, linking our universe to others or even birthing entirely new universes on the other side of the collapse. Others warn that the singularity is simply the edge of the fabric, a place where our cosmic cloth runs out of thread. The truth, we don't know. Every black hole could be a wound, or a doorway, a tear or a tunnel, a secret the fabric keeps until we find a way to peek inside. Up until now, we've treated space-time as a smooth, flowing cloth. But what happens if we zoom in? Not with a telescope, but with the sharpest microscope imaginable. At scales smaller than an atom, smaller than even the particles inside an atom, we enter the quantum realm. Here, certainty dissolves into probability. Particles flicker in and out of existence like fireflies in the dark. Physicists believe that space-time itself, when seen at this imaginably tiny scale, may not be smooth at all. Instead, it could look foamy, jittery, pixelated, a seething quantum froth where distance and time lose their meaning. This idea, called quantum foam, suggests that the fabric of the cosmos is made of microscopic threads of uncertainty, endlessly shifting, endlessly bubbling. So if space-time is fabric, what are its threads? One possible answer lies in string theory. Instead of tiny point-like particles, string theory imagines the universe's building blocks as tiny, vibrating strings. Different vibrations make different particles, like the notes of a cosmic violin. The fabric of space-time itself could emerge from their music. Another approach is loop quantum mechanics, where space-time is woven from tiny loops, linked together like a mesh. These loops form the fundamental atoms of space, giving the universe its texture. Both theories try to explain what happens at the edge of black holes, at the birth of the Big Bang, and in the hidden places where Einstein's smooth space-time and quantum mechanics clash. But if either theory is right, then space-time isn't fabric at all. It's threads, it's loops. It's something deeper than the word space can describe.
Let's pause, drift, and ask if space-time is woven from quantum threads, who or what did the weaving? At the Planck scale, the absolute smallest scale in physics, distances are so tiny that even light takes almost no time to cross them. Here, the smoothness of space-time dissolves into quantum chaos. Time may no longer flow, space may no longer stretch. Cause and effect themselves may blur. It's like looking too closely at a dream,
The sharper you focus, the fuzzier it becomes. And yet, from this microscopic chaos arises the vast, orderly cosmos. Galaxies, black holes, the night sky we gaze at, the calm rhythm of time ticking onward. This is the paradox. The largest scales of the universe are written by the smallest. The cosmic fabric is born from invisible stitches, too fine for us to see, but strong enough to hold everything together. Imagine walking across a giant sheet, the fabric of the cosmos itself. Step after step, galaxy after galaxy, forever stretching out. The question arises, does this sheet ever end? Scientists have wondered the same. Is the universe infinite, with space-time going on without limit? Or is it finite, curved back on itself like the surface of a balloon? No edges, but if you travel far enough, you eventually return to where you began. And here's the haunting thought. If space-time does have an edge, what lies beyond it? Is it nothingness? Or is it something else entirely? A realm where the word space no longer applies. We've spoken of rips, tears, wormholes, and singularities, but can space-time actually break? General relativity says no. Space-time is continuous, smooth, unterrible. But quantum mechanics whispers a different story. At the Planck scale, space-time may froth, foam, and fluctuate. Tiny tears may constantly appear and heal, like sparks in a fire. The idea of space-time tear becomes especially vivid in extreme scenarios. At the heart of black holes, where density becomes infinite. During the Big Rip, a hypothetical future, where dark energy grows so strong it shreds galaxies, atoms, even space-time itself. If that happens, the universe doesn't just end. The fabric itself unravels. The loom of reality falls silent. Every fabric phrase, every story has an ending. But how will the fabric of space-time end? Physicists imagine several possibilities. The Big Freeze. Expansion continues forever. Galaxies drift apart, stars burn out, and space-time grows cold and empty. The Big Crunch. Gravity wins. The universe collapses back inward, folding space-time into a final singularity. The Big Rip. Dark energy grows so fierce that it tears apart galaxies, atoms, and space-time itself. Heat death. Entropy takes over. Not a tear, not a bang, just a slow fading into uniform nothingness. Each scenario is unsettling, yet strangely calming too, because whichever fate awaits, the fabric is vast enough to hold countless billions of years before its final chapter. And perhaps endings are not endings at all. Maybe from the fading threads of one universe, a new fabric is woven, beginning the dream again. For billions of years, space-time has stretched, bent, and whispered its laws into the cosmos. And yet, here we are, fragile creatures, living on one tiny patch of that infinite cloth. When you walk across the floor, you're really gliding along space-time. When you glance at the stars, you're peering through folds of the fabric, light rippling towards you across billions of years. Even your heartbeat, ticking second by second, is space-time marking the rhythm of your existence. We are passengers on this fabric, but we are also expressions of it. The atoms in your body were forged in stars, sewn into the universe's tapestry long before you were born. In a very real sense, the fabric is not just around you, it is you. But here lies a mystery. If space-time shapes matter, and matter shapes life, could space-time also shape consciousness? Some philosophers wonder if the mind isn't just inside the brain, but partly woven into space-time itself. After all, thoughts unfold in time, and awareness stretches across space.
Perhaps our consciousness is the fabric noticing itself, dreaming of its own existence. Even physicists ask bold questions. Is time an illusion, created by the brain's way of interpreting space-time? Does consciousness require the flow of space-time, or is it something deeper, something that could exist beyond the fabric? When you close your eyes, drifting into sleep, the border between inner thought and outer universe blurs. Could it be that space-time itself is dreaming, and we are its fleeting visions? At last, we come to the most poetic possibility, that reality itself is less like a rigid machine and more like a dream woven from space-time fabric. Think of it. Dreams feel real until you wake up. Time flows in them, space stretches, yet the rules are flexible. Could our universe be something similar? A grand, persistent dream held together by laws of physics instead of the sleeping mind? Mystics across cultures have whispered this idea for millennia, that the universe is Maya, illusion, a tapestry woven for consciousness to experience. Now physics hints at a similar truth, that space-time is not ultimate reality, but an emergent phenomenon, a story told by something deeper. And so, whether we live in a dream of the cosmos or the cosmos lives in the dream of space-time, the mystery remains. A fabric so vast, so delicate, so strange, that we may never fully awaken from it. Here's a twist. What if the fabric of space-time isn't fundamental at all, but a projection? Some physicists believe our universe may be holographic. Imagine a 3D movie projected onto a flat screen. The depth looks real, but the information is stored on a surface. Likewise, everything we see, galaxies, black holes, even ourselves, might be encoded on a cosmic boundary, with space-time emerging as an illusion. Black holes actually inspired this idea. Their surfaces, the event horizons, seem to store all the information about what falls inside, as if reality itself is written on a cosmic page, and what we live in is just the reading of that page. If true, the fabric of space-time isn't cloth at all. It's a shadow, a mirage, a beautifully convincing dream projected from a deeper truth we can't yet touch. But what if our universe is not the only quilt? The equations of inflation, quantum theory, and even string theory suggest the possibility of multiple universes, a multiverse, where each cosmos is stitched from its own space-time fabric. Some may have different physical laws, where light bends differently or time flows in strange loops. Imagine countless fabrics, each floating in an infinite loom, some frayed, some smooth, some never giving birth to stars. If the multiverse exists, then our universe is just one patch of cloth in a cosmic quilt far beyond imagination. And here's the mystery that keeps thinkers awake at night. Are these universes forever separate? Or could their fabrics sometimes brush against each other? If so, perhaps déjà vu, strange coincidences, or unexplained mysteries are hints of other fabrics brushing close to ours. Every fabric has a pattern. Every pattern has a rhythm. What if space-time has a music of its own? Einstein once said that the deepest truths of nature are mathematical, and math is often compared to music. The oscillations of strings and string theory, the vibrations of gravitational waves, the hum of quantum fields, all of them suggest that space-time may not just exist, it may sing. When black holes collide, they send ripples through space-time. Detectors like LIGO listen to these ripples, literally catching the faint echoes of cosmic events billions of years away. It's as though the universe plays chords across its fabric, and we are just beginning to hear them. And maybe, just maybe, consciousness itself is tuned to this cosmic symphony. Small brains humming along with the vast orchestra of space-time, unknowingly part of the melody. Time feels like a river, always flowing forward. But what if the fabric of space-time can fold, twist, or loop? Einstein's equations suggest that time travel isn't forbidden. If space-time can bend into wormholes, then journeys to the past or future may be possible. Some solutions, like closed time-like curves, describe paths through the fabric that loop back on themselves, allowing you to step into your own yesterday. But with time travel comes paradox. If you prevent your own birth, who prevented it? If you meet your future self, who wrote the meeting first? Perhaps the fabric protects itself, closing paradoxes like a self-healing cloth. Or perhaps time, like a dream, is less fixed than we think, flexible enough to allow rewrites, yet mysterious enough to hide the consequences. Some physicists imagine a universe where time itself loops. Instead of stretching endlessly, the fabric may roll back upon itself, forcing events to repeat. In such a cosmos, the rise of stars, the fall of galaxies, even your life could play again and again like a cosmic record spinning eternally. Every decision you've ever made might already be etched into the loop, repeating across infinite cycles. Is that terrifying or comforting? To know that the dream of the universe might be eternal, that nothing is ever truly lost, only played again, endlessly, across the fabric of time. And so, dear wanderer, we arrive at the final thread. We've drifted through the birth of the cosmos, the stretching of inflation, the mystery of dark energy, the collapse of black holes, the whispers of wormholes, the smallest quantum threads, and the largest multiversal quilts. We've asked whether the fabric sings, whether it dreams, whether it will tear, and whether it will end. Perhaps the truth is this: the universe is both fragile and infinite, both woven and unwoven, both real and dreamlike. And as you close your eyes tonight, remember, you are lying gently upon that cosmic fabric, part of its weave, part of its story. The fabric holds you, just as it holds galaxies. So rest, dreamer. Drift with the wandering neuron. The fabric is vast, the questions endless, and the night sky will keep its secrets until you are ready to wander again. Goodbye, for now.